Good day to everyone. My name is Mark Van Buladaco. I'm from Davao del Norte State College. So, what we're going to discuss today is a data structure called Stack and how it is applied to different applications. So, basically, Stack is a linear data structure wherein we can store elements and objects within its storage. Elements can only be accessed on the top of the list or the stack. So this is a container of objects, and stack is implemented using the last in and first out principle, wherein you can only access those top elements within the list. So stack is basically similar to those stack of trays in a cafeteria, wherein you can only put new trays on the top of the stack, and you can remove trays only also on the top from the top of the stack. This is the reason why this is called last in first out structure or LIFO structure. So this is an example of a real world comparison of stacks in programming language. So as the plates is also the same with the trays in the cafeteria, wherein you can only put new stack on top of the stack, new plates on top of the stack, and you can remove plates from the top of the stack. Another application or real world application of stack is a mathematical puzzle or game called Towers of Hanoi. Towers of Hanoi consists of three rods and discs of different sizes. So you basically um, place the different size discs on top of each other, but you cannot put larger discs on top of a smaller disc. So you can search Towers of Hanoi. There are online games so that you can learn how to play with it. So basically, stack is defined by its operation. In many programming languages, there are several um, methods or operations of how the stack can behave. In this list, as you notice, these are the basic and common operations with across different programming languages. So we have here clear. The clear operation basically remove the elements from the stack, and the empty operation or methods is it will test or it will return true if the stack is empty, and it will return false if there are elements inside the stack. Another important operation will be the push operation. So this element will basically add elements in the stack list or stack array. So please be reminded that the pushed element or the added elements will only be placed on the top of the list, or the top, it will be considered as the top element. Another important method or operation is the pop method or operation. So this will just remove the topmost element in the stack. Lastly is the top L operation. The top L operation will just return the topmost element without removing it. So this is a visual representation of the push and pop stack operations. Again, when you push elements inside our stack, you basically add it on our list. So when you add it on our list, it is added on top of the list. So here we push element 10, and element 10 is added in our list. And we have another added element, which is 5. So push 5. So the element 5 will be inserted on top of 10. So the new top element now is the element 5, as you notice here. So we have another executed operation, which is the pop operation. So in the pop method or operation, it doesn't need to specify a value because it will just remove the it will access the topmost element and remove it. So once you execute the pop operation, um, the topmost element as of the moment is 5, so it will be accessed, and then it will remove. As you notice, this is the result. When we push another element, which is 15, it will then be added on top of the list. So this is now the new list, as you notice. So 15 is the topmost element. And then we added a push again 7. So the new topmost element is 7. And then we have a new pop operation here. So basically the topmost element will be removed. So the topmost element as of the moment is 7. So 7 will be removed of the list. So if there are no other operations, so basically the last um, arrangement of our list is 15, which is the topmost element, and 10. A good application of stack data structure is what is the delimiter matching algorithm. In different programming languages, we use delimiters in order to specify the different uh, scope of our statements. In Java programs, we have delimiters called parentheses, square brackets, curly brackets, comment delimiters. So these delimiters must have a partner on each other. So if there is an open parenthesis, there must be a close parenthesis. So we have known that if you study programming. So this is an example of a Java statement that basically used delimiters properly. As you notice in our statement, we have a variable a that is equal to b, and then we have the notation of the add, which is plus, and then we have a starting delimiter of a parenthesis or open parenthesis. So the compiler will basically wait for the close parenthesis in order to close the statement. So we have the open parenthesis, then C minus D, and then the close parenthesis. So basically, this is a proper way of using delimiters. And then we have a multiplication sign, and then another open parenthesis, which starts a new statement, and the compiler will basically detect if there is a partner of the open parenthesis. So open parenthesis, E minus F, and then the close parenthesis. So the compiler will now execute the statement. So these are some other statements in Java that uses delimiters properly. So in this statement, it uses square brackets. As you notice, there are multiple square brackets in each variable. I think this is an array. And then, as you notice, there are two open here. There are two open brackets. So the compiler will must detect two close brackets in order to complete a specific identifier of the array or the statement. Then this is another um, example of Java statement that uses delimiters. So this is a while statement. So it has all of the delimiters present in Java programming. We have the open parenthesis that utilizes the while statement for the condition of the while statement. We have the square brackets for accessing the array, and we have the curly brackets in order to justify the scope of the statement. We also have here the um, comment delimiter, which is forward slash and asterisk. That's the open comment delimiter. And then we have the comment initialize p. And then we proceeded with a asterisk and forward slash. So it basically closed the entire comment. So these are the examples of statements that did not properly use the delimiter matching, or there is mismatching occurs. So in this example, it's similar with our first example in our previous slide. But as you notice, at the end, there is a close parenthesis. So basically, the compiler will expect that there is a open parenthesis that partners the exceeding close parenthesis. So on the last parenthesis here, it doesn't have a partner open parenthesis, so the compiler will issue an error. Same with the second statement. We have here another close parenthesis in the k variable. It doesn't have any partner open parenthesis. So basically, the compiler will issue an error. Same with the third statement. So all of these statements will have, of course, a mismatching of delimiter. So basically, mismatching of delimiter will issue an error from the compiler of the programming language, or in at this case, we will utilize Java. So the delimiter matching algorithms will basically read a character from a specific Java program, and those though this is basically the entire algorithm of how to detect delimiter mismatching or matching of delimiters. So the delimiter will be detected and it will be stored in a stack of the opening delimiter. So only the opening delimiter will be stored in the stack. So if a closing delimiter is found, it will then compare whether the closing delimiter is the same with what is the top element in our stack. If it is the same, the stack the the top element will then be removed. That means the two delimiters are the same or in partner with each other. If it's an open parenthesis, so it must have a partner of a closed parenthesis and so on. So if they match, processing will still continues. And if they will not match, the the program will signal or issue an error. That means the statement on that line has an error on its delimiters. So the processing of Java program will basically end if there are no errors until the end of the program is reached and basically the stack is also empty. So as you notice, this is basically the algorithm of the delimiter matching. So in this method, we have the delimiter matching method that will access or accept a Java program file. It will read each characters from the file, and then we have here a while structure, a looping while structure that will read on the course of all of the characters in a Java program file. We have here an if structure, a decision structure that will detect whether it is an open delimiter. So we have here the open parentheses, the brackets, and the braces. If it is an open delimiter, it will be pushed. The character will be pushed to our stack. So as you notice here, we have a push operation. Else, if the character is a forward slash, it will then determine if it is an opening of a comment delimiter. So it will need to read the next character. If the forward slash proceeds with a asterisk, that means it is an open delimiter. It will skip all of the characters. That means it will still need to read the characters until it will found a asterisk, asterisk, and forward slash, and report an error if the end of the file is reached but it doesn't encounter any asterisk or and forward slash, which means that is the ending comment delimiter. Else ch or the character is equal to the character read in, it will then be continued. And then we have another else if clause here. So it will read if the Character is an ending delimiter of parentheses, brackets, and braces. So if these are the characters, the character in the topmost element will be pop off. So we sometimes call it as pop off if you want to remove the topmost element in a stack. And then if the character is also pop off delimiter do not match, there is a failure in the program. So we will read the next character from the file and we'll go back again to the while loop until the stack is empty. This is an example of a let's have an example of how the algorithm works. So we have here an input statement. We have a series of characters in this statement here. So it will read the leftmost character. In this case, the leftmost character is S. As you notice, the letter S is not a opening comment delimiter. If it is not an opening comment, if not a opening delimiter such as parentheses, brackets, and braces, it will just read the character but it will not be placed in the stack. So basically at this moment, the stack is empty. It will read again another the next character which is an equal sign, same with the first character. It is not a not it is a not a character parentheses, brackets, or brace, so it will not be placed in our stack. And it will read the letter T, which is the variable for our array, and then it will read the open bracket. The open bracket is basically um, a opening delimiter. So if there's an opening delimiter, it must be pushed within our stack. So as you notice here in our stack, we already have an element which is the open bracket. It will then read another number or another character. So as you notice, the character will be read. So which is the number five. That is not a opening delimiter. So it will be just be read, and then the um it will read the next character, which is the close bracket. So the close bracket is basically um the part it will if the close bracket will be read, it will check in the stack whether it is a partner of the close bracket. So in our stack, we have an existing open bracket, and our currently read um, character is the close bracket. So basically, this open bracket will be popped off. And then let's proceed with the here at this part here. It reads the open bracket. So the open bracket will basically put into the stack and then it will read again the next character, which is V, and then the multiply sign, and then another open bracket. As you notice, when the next open bracket is read, there are two open brackets that are read in our in our stack. So it will read again. It will be placed in our stack. So there we have already two elements in our stack, which is two open brackets, and then it will read again the W plus and the Y, and then it will read the close bracket. I mean parentheses rather. Sorry, open parentheses parentheses, and then it will read the close parentheses, and then once it will read the first close parenthesis, it will check the stack if it is a partner of the close parenthesis. As you notice, the topmost element of our stack is an open parenthesis, so it will be removed since it is a partner of our red character. And the lastly, we have the another close parenthesis. So we have still another existing element of our stack. So it will be pop off because the red character is a close parenthesis. And then until the end of the file will be read and then the stack is empty. Another application of backtracking of stack is backtracking. This is basically the same with how we play in a maze or a puzzle or a game. In games, it basically records the last position that you had moved. So if you will move to a dead end, example in a labyrinth or maze, and then you see yourself or the character or in the game you're in a dead end, you need to backtrack. So when you backtrack, you basically access your last position, which is basically can be accessed on the stack or the topmost element of the stack. So once you reach a dead end, you must backtrack. So therefore, at each choice point, you store on a stack all possible choices. So when you move around the maze, you put each of your position on the stack. So when you backtrack, you can easily access your previous position. So stack is basically available in Java programming. It is under the Java.util package. It is an extension of the class invector. Again, as I said earlier, that stack can be implemented using array or linked list. We'll have another laboratory exercise on how to utilize stack in Java.util on our next videos. A stack can be created using this declaration and initializations. As you notice, this initialization is the basic initialization and declaration of our stack. So these are the methods of our stack in java.util. So it represent or reflect the common operations in our stack. So we have here the empty, which is reflects the is empty. It will return true if the stack includes no element, and false if there is an element inside the stack. So we have here pick. The pick method in our java.util, that stack will return the topmost element. It will not remove the topmost element. And then we have the pop, as it's the same with our common operation. The pop will remove, access the topmost element, and remove the topmost element. It will throw an exception if the stack is empty. It will throw an empty stack exception. And then we have here push method. It will insert the specified element on top of their stack and return it. If you want to um, output the pushed element, you can basically include it in a system.out.print statement if needed. And then we have also the search. This is the similar with the pick. However, in the search element, it will return only the position of a specific element on the stack. Example, you want to search, let's say, an element 10. So what is the index or the position of element 10 within the stack? It will return -1 if the element is not found in the stack. So that's all for today. So basically we have learned about stack data structure and its operations. So on our next lesson, it will be about queues. Thank you for listening.